and minimize it. There we go.
All right. So let's see. Let's get back to that first one. There we go. Okay, so what I'm going to be talking about today is just migrating an application to Docker. How familiar are you folks with Docker? Somewhat. Okay. So Docker, as you probably know, is just it's a containerization technology. It's built upon existing technologies like LXC, uses C groups now, things like that. So it's very lightweight. People try to compare it with virtualization. It's a little bit different. You don't have a virtualization layer. It's just a container, and actually all containers use the same kernel on the host. So it's just a very lightweight way of running applications. And it keeps them segregated, and it's just a really good way to run applications. It requires a little bit different way of thinking, but once you get used to that, you'll find it helps your workflow a lot. It's great for development, rapid development. Who am I? I'm Mike Klatsky. I'm the VP of Systems for Esperdyne Technologies. I've been in systems for 18 years. A lot of my experiences within ISPs, JavaNet became RCN, Connecticut Telephone, TNR Global, and now Esperdyne. Architect and build systems at AWS, Rackspace, DigitalOcean. We have a meetup, Western Mass meetup, if you're interested. It's been the fourth Thursday of the month. We're going to be changing that probably to the fourth Tuesday. I'll be posting that up on meetup.com. I've got a couple of rescue dogs, 3 cats, and I brew beer at home. So that's me. Who's Esperdyne? That's the company that I work for. We've been in search for 10 plus years. A lot of experience in that area. We focus on ESP, Solar, Elasticsearch, and the cloud. We're, as it says, experts at scalable web and search solutions, and we provide managed infrastructure and services. So initially what we want to cover is what application do you want to migrate into Docker? We start out with an application which is what they call monolithic applications. So you've got a web server. We're just going to say one server. You're running a web app like Drupal, which runs under Apache, could run under Nginx, anything, but it's typically run under Apache. You can have a database server. Lots of times that database server runs on the same system. To scale, you don't want it on the same system, but for a smallish website, you have everything on one host. So when you're identifying what you want to use, you're going to identify the application first, and then you have to break apart the components, because one part of containerization is you don't want everything in a container. You don't want to take your monolithic application and then just drop it into a monolithic container, because you haven't received too much of a benefit other than isolating it from other things on a host. Ideally, they also, I've heard the term microservices used interchangeably with containers, but microservices are actually the things that run within the containers. And so typically, you're going to separate the components. So you're going to separate your application, you're going to separate your DB server. And as it states, separate the code, the data, configs, performance, and for management. Some of the applications, Drupal. I'm doing Drupal today just because a lot of people here know Drupal. It's a very Drupal-centric conference, so I figured that was a good one. Redmine, we're running production Redmine. I've run production WordPress. We're running our OpenFire Jabber server. We're running GitLab. We're running an app called Uptime, which is a really cool way of monitoring websites, content-aware monitoring. We're not running an OpenVPN server in production now. I'm doing testing on that, but I've done it in testing for several months, and it runs beautifully. We have an Elk stack that's running. We're testing it right now. It's production ready, but we're not using it in production yet. And I put down the different technologies it uses because it's pretty neat, because you can run, one of my colleagues talked about Celery. You can run Celery in a separate container from other things. You can run Redis in its own container. So you really break apart the different services, and it allows you to distribute them across multiple hosts. Although today I'm going to be concentrating on everything's on one host, just for simplicity. So we're going to look at Drupal. You've got multiple components. You've got the web server, Apache. You've got your Drupal code. You've got your settings. And then you've got a database server, which in this case is MySQL. It could be PostgreSQL or almost any other one that.
When you say settings, are you talking about just settings.php?
Pretty much. That's really what it boils down to.
Okay, so you config stuff.
Yeah, exactly. Right. And database data. So those are going to be the separate components. We're going to use the Apache web server. It's going to be containerized. You can tune it just like you normally would tune it. You can set max clients and whatnot. And you would do that when you build the container. That's the best way to do it. You can present the configs outside of the container. I typically don't. If I find that my web server container isn't performing properly, I make the changes in the Docker file, and then I rebuild the container and then relaunch. And one thing that's really nice is you have, when you do a launch like that, you almost have no downtime, because a container comes up, oftentimes it can come up in a split second. It depends on how much stuff has to be done. A Redmine container, oftentimes when it comes up, it runs through the migrate process, the Rails migrate process. That takes some time, so it's not quite as seamless. It's seamless from a management standpoint. You stop the container, remove it, relaunch from the new image, it comes up and everything looks as it should. But it just takes a little bit longer, and that's just inherent to the technology. Of course, an Apache web server is kind of useless without it doing something. So the Drupal container includes the web server and the Drupal code. The Docker file, which I'm going to show you momentarily, handles copying your Drupal code base. In the Docker file, if you're just deploying a new Docker instance or a new Docker Drupal instance, you can download Drupal and then you can expand it and put everything into place. But we're doing it a little bit differently because you've already got a code base. You want to move that into the container. So we're not going to do it in exactly the same way. There are also a couple of settings that require modification. If you're running MySQL on the same host as your Drupal instance, in settings PHP, your DB host is going to be localhost. You can't use localhost anymore because you're not running MySQL in the container, so there's no concept of localhost for the database. For the configs, again, probably just settings.php, but I know I've seen people who have multiple configs using various includes and stuff, and it gets a little bit messy, but they do it. Your configs can live outside of the container, and by that I mean you can present various directories that are on your host. You can present them into the container. And when you do that, when the container goes away, when you stop it, when you delete it, those configs, that data stays on the host, so it persists. Why is that valuable? Well, you can just update the configs on the host and you can restart the container. Or you can update the config, and let's say you've updated your image. So let's say there's a new version of Drupal and you don't go through the regular upgrade process. You're going to upgrade by upgrading your image. You're going to kill the container, bring up a new container. It's going to pick up those same configs. So you don't have to go messing around with making sure you persist the configs within the container. And that's one thing to always remember when you're thinking about what stays in the container and what you want to present from the host into the container. A Docker container, when you remove the Docker container, the data within it is gone. So you can also include the configs within the container. If you want to update those configs, then you need to do an image rebuild. And then you relaunch the container again from that new image. So it depends on your use case. You know, I know people who run Drupal, very busy Drupal installations, who have never had to reset their settings PHP. It's been like that since they started it. So if that's the case, leave it within the container. It's a little bit simpler, and you just rebuild the image, and it keeps the settings. So that's, yeah, you think about how often you modify the configs. And think about the files too, the things that are uploaded into Drupal. There's a lot of stuff that, the user generated content that's not in the database, but files and documents and stuff that are uploaded. You're going to want to keep those outside because you don't want to lose them. So when you do a Docker run, you use something along the lines of the -v means present this volume. So this is what's on the host, the op Drupal files, and present that into app sites all, which is where you have the where you have your app sites default app sites all. That's within the container. Or actually more properly would be op Drupal files app sites all files. So you present that into the files directory within the app. So if you killed it, it doesn't matter. Those files that your clients or your customers have uploaded are still there. When we get to the database server, it's a little bit more complex because data is stateful by its nature, and you need it to be consistent. So you can't just copy the directory over. You can't just tar up the directory. So when you use a MySQL database container, we can tune it when building the image, or you can place the configs outside of the container and updates and restart of the container if you do that, similar to the Drupal container. When it comes to your database data, it should always live separately from the container. Couple of reasons. One of them is portability. You want to be able to move it from host to host. Also, if you're in a VPC at Amazon and you want to be able to use GlusterFS, or if you want to use one of the newer technologies, or EFS, where you want to share a file system, you can do that. You get some locking issues when it comes to MySQL, but you can also replicate and keep that data consistent. So if one database server goes and you lose data, you've got live data on another system that you can bring in.
So if the MySQL server is in a container,
yes,
and the data's not,
right,
where is the data then?
The data lives on the host.
Okay, just kind of next to the containers?
Yeah, what you're doing, you know what bind mounts are? Where a bind mount is where you can take a directory on a server and you can mount it to multiple locations.
Okay.
And it's a good way of presenting things like, for example, if you have a web developer that you don't want to give access to the var dub directory, what you can do is you can mount the var dub directory as a bind mount within their home directory, and they can then make the changes. They just log in, make their changes within their home directory, and it's live within var dub.
Gotcha.
And that's
whether you want them to have live access to your server, that's a different story. But
that's compared to a symbolic link, that is just
right.
that much more speed-wise, or
speed-wise, but you can also mount to multiple locations too. So you can have 4 web devs all logging into their own home directory, all making changes on the same directory elsewhere.
Okay. Well, you could create 4 separate symbolic links.
Why bother?
Okay, so it's just
this
less
way
headache.
Yeah, exactly.
All right.
Exactly. So it's a pretty powerful way of presenting information or directories elsewhere.
Well, I think maybe there might be, data that you want to keep, you should definitely live separately from the container.
Oh yeah.
But they're like things that are maybe temporary message queues or something that if it's scalable, so for something that's just like a single instance primarily will run,
yep,
you definitely want to do that. I can see where if you want to try to make something that would scale, that it would be hard to have a strategy to have it on disk unless there's like per Docker container file path or something.
Yeah, well, you present. I think what you're talking about is if your app needs to create temporary files that are short-lived.
Well, yeah. So like in one scenario is a database server, like MySQL. You wouldn't have 5 MySQL servers, but you would have 5 Apaches possibly, or 5 something, 5 services.
Right.
So in those cases, you might may not want it to be like you may want the config files to be local, separately from the container.
Well, theoretically, you could have 5 MySQL containers. They don't all have to be. You don't have to have them all under op MySQL DB.
Right.
You can have them in different paths.
Right. So you need to have some sort of strategy for that.
Right, right. So, I mean, if I was going to run multiple MySQL containers on one server, I'd probably do opt container name or container ID, something like that, so there'd be no name collision there.
Okay.
But yeah, short-lived data, stuff that doesn't need to persist.
Yeah.
If it's disk-based, it depends on what kind of performance you need in terms of scalability. And I get into that a little bit with performance inside of the container, because inside the container, you're limited to the Docker backend storage subsystem. And so depending on the version of Ubuntu you're running or CentOS, the defaults have been AUFS, which has some performance limitations, ButterFS, and then Device Mapper is what the standard is right now, but it's for later kernels. I think you need a kernel later than 3.18. So that's like the brand new version of Ubuntu, unless you install the backported version on Ubuntu 14.04, something like that. And this is kind of stuff this is like weeds kind of stuff. You don't really need to know all of this. This is when you're starting to do scalability and get your best performance. But if your average Drupal instance that needs to get a couple of thousand hits a month, for some person who just has a small store and they're not getting that much traffic, it doesn't really matter that much. But once you start scaling, this is where you start seeing performance bottlenecks. Device Mapper using ThinP, thin provisioning, it's got some performance bottlenecks. So a way of getting around that performance bottleneck within the container is using Device Mapper with LVM. And then you've got all the advantages of the speed of LVM without the problems that you have with the thin provisioning. But for the most part, when it comes to data, toss it outside of the container, and then whatever your file system is on the host, we run, depending on which system, some systems run ext4, and some of them are running XFS. In fact, most of ours are running XFS, and so we get the performance out of that. The other advantage of having, especially when it comes to database data, is that you can use your existing tools to back up that data. And that makes it pretty easy to back it up. You can also, if you have XFS or if it's living on LVM, you can do snapshots. So again, another pretty easy way to back up. And again, you don't lose data when the container is removed. So that's pretty powerful. There's some, I didn't put this in here, but there's some really cool, the latest version of Docker, which just came out not too long ago, has plugins now. And there's some really cool storage plugins that are out there. One of them is called Convoy. Convoy is by a company called Rancher Labs. And what's really nice about Convoy is it allows you to literally move a container or move data from host to host very easily. And the way it does that is it does a snapshot, and as part of the snapshot, you can have it automatically back it up to S3, and then you can pull it back down on another host. So it's very easy to make automatic. So another container comes up, it uses that storage backend, you tell, and in your script, you tell it where that storage lives, and it pulls it back down, and you've got an exact duplicate. There's also something called Flocker, which actually does a live migration of data from one server to the other server. And that's pretty cool. I've done that in testing. I've not done that in production yet, but I've actually moved a MySQL server to another host while a front-end web app was working, and I didn't see any kind of an impact. And it was pretty cool. It wasn't a big database. It was about 10 gigs, but still, I mean, it was pretty neat to watch. So what are the steps that you need to do to get your existing code into a container? So the strategy that I have is I use a Docker file to build my container for Drupal. And I'll show you the Docker file after. But on the source server, I'm just tarring up the code because it's all code. It's nothing fancy. It's just a bunch of code. And then you copy it into your local Docker project directory. I tend to have all of my Docker projects named Docker Technology. So it's docker-Drupal. Come on in. That's right. So I just do, docker-drupal. I know what it is. It's all under Subversion, all under Git control, version control, and that's it. So I tar it up, copy it into my local Docker directory. And then I just do, it's just a standard MySQL dump of my database. I copied that into my local Docker directory. Now this is my Docker file. If you look, it's fairly self-explanatory. I mean, they're really simple. This is just the image that I'm using as the base. The way Docker builds its containers, it builds up layers on top of each other. So it runs a command. So it's going to run this command, and then this whole command here. And then it's going to, best way to describe it, it does a git commit on the existing container that it just ran to run that command. And then it launches a new container based on this and runs this command, does the same thing, commits it, and then it keeps on doing it through each iteration of commands until you have a bunch of layers, and then you've got an image. So what I'm doing here is I'm installing MySQL, I'm installing Supervisor, because Supervisor is what manages the run of Apache. I'm creating my app directory, and now I just have a directory that was nerd that has my in my Docker directory that has that tarball of my app. The add will automatically, there should be a space there, the add will automatically take that file, it knows it's compressed, it'll decompress it under app. So it's taking my code, automatically bringing it to app, decompressing it, so I now have all of my Drupal code right there. However, there's one small problem. First of all, I've got to make these, I have to give these the right permissions, but my settings.php file points to localhost. It doesn't point to the environment MySQL, the MySQL container that's living on the host. So that's an environmental variable called MySQL, just something simple. So all I do is I just replace my localhost with MySQL in settings.php, and I'm done. Expose 80 means I've got to expose port 80 on the host from this image when it runs, and then that's the command that it runs. It takes, the first time I ran this, I'm running it on a fairly small instance. It took about 3 minutes to build the image. So what are the steps? Well, using the above Docker file, once I have that Docker file, I mean, the best way to describe what a Docker file is, it's kind of like a make file for Docker. It's pretty simple. It uses standard Unix commands. You copy things in, you run things, you install things. So using the above Docker file, I just run docker build, -t means to tag it. Otherwise, it just generates a random name and a long, I think it's like a 32 character hash. And then the dot means within the Docker container. That'll run, it'll build the container. It fixes the settings PHP to access your database container, and that's it. So nothing crazy. Now to prep the database, this is the manual way. You can do it in an automated fashion, but I want to go through the manual way. I'm not going into the automated way of doing it because it's valuable to know how to do it manually. So you prep the DB. What you've got to do is you've got to create a database in the new container. You've got to create the grants, and you get those from settings PHP, of course. And then you import the MySQL dump into the MySQL instance that's running within that container. So if you look at this, it looks like a lot of kind of gobbledygook. But if you actually look at what commands you're running MySQL admin create the Drupal DB, MySQL admin or MySQL grant onto that DB. You're adding the grants. And then here you're just doing a MySQL and you're importing the Drupal SQL file. The stuff that comes before it is you need to do this within your running MySQL container, because that's where MySQL lives. So the Docker exec, what that does is you do Docker exec -ti, gives you a sudo tty, it's interactive, and this happens to be the name of my container. So you're basically, it's essentially the equivalent to shelling into the container, running this command, and then you're done, and it shells back out. There used to be another tool. They used to not have this in earlier versions of Docker about a year and a half ago. So there was another tool called NSEnter that allowed you to do this. Also, a lot of early people, what you do is you build an SSH server into your container, but you don't really need that now. So that's one less process, one less package that you have to have running within your container. So that's all you do is you create your Drupal DB, you create your grains, you import the Drupal DB SQL file. Now, I put this a little bit out of order because you can only do that when your MySQL container is running. So you need to use this first. And what this is, there's a tool called Docker Compose. It used to be called Fig. There's a company called Orchard Up that did some really great work with orchestration. And Docker bought them. It's 3 guys in England. They were a year old, and Docker bought them. So that's pretty cool. And they're now Docker's British branch. So what this is it's a YAML file which just describes what your stack is like. This stack only has 2 things. It's got a web container and it's got a MySQL container. And you can see that just right there, web and MySQL. If I decided that I want this sitting behind Nginx or HA Proxy, which is how I typically do these things, I usually don't have anything going right to Drupal. I'll also have Varnish, and oftentimes, most of the time, Memcache. So I'll have a more complete stack when I'm building this out. But for this, so the image, I'm just telling it test Drupal, which is the image that we just built from that other Docker file. Volumes, this is where I'm presenting the volume on the host into the container. The link, what this does is it's saying, okay, MySQL, the MySQL image is called MySQL within web. And what this actually does is it becomes aware, it's aware of this MySQL container when it launches. So it writes the host name MySQL into the etc host file on here. And it writes the internal IP address of the MySQL container. Basically what it does is it makes it so that these 2 can communicate with each other. Otherwise, you've got some manual work to do to make them talk to each other. Or you've got to present MySQL externally onto the host, and you don't want that. You don't want it to be accessible externally. Ports, I'm just mapping port 80 to port 80 internally. Sometimes when you're running, Rails app that runs on port 5000, you'll do port 80 to 5000, just so you don't have to have somebody coming into port 5000, have firewalls open and that kind of thing. MySQL, I've got my own MySQL container, but for this one, I specifically wanted to use this guy. He's done a lot of good work with containers. His MySQL container is really, really good. There are a couple of things I've changed in mine, but I made those changes late last night. I didn't want to make the change here and make you guys go astray. And then here, I'm just presenting the volume of Drupal MySQL into var lib MySQL, again, to make sure that we keep the data outside of the container. And then I'm setting up an environmental variable, the MySQL root password. And if we saw that slide before, I had that long line where I also had to enter the user and the password. That's this password. All this does is it sets the root password for this instance. So to run this, to use this, instead of having if you've ever seen a long Docker, I should have put that in here, a long Docker run line. It's very long, it's pretty ugly. With this, all that is described here. All you do is you run Docker Compose up -d, and the -d just means demonize. If you run it Docker Compose up, it'll run up, it'll stay in the foreground. So you can watch the logs as they go by. And it's pretty cool. Docker Compose, you can also do Docker Compose PS. It'll tell you what containers are running for this app stack. Docker Compose logs, it'll show you the logs for that particular app stack. And it's nice that it is only about this app stack. So if you have other containers running, it doesn't care about those, it doesn't know about those, it only knows about these. So that's a Docker Compose YAML file. So the results mean that there's no more monolith. You don't have one application running all at once. Let's say you have a dozen customers. You can run one of those containers for each of your customers. And that's where something like Nginx or HA Proxy would come in, because there are ways, some pretty nice ways of leveraging those so that you can actually, when a new instance comes up, you have service discovery on your hosts. The service discovery registers with a localized DNS, which is part of the service discovery, and HA proxy or Nginx can, there's a process that listens for that, rewrites a new config file, reloads it, and boom, your new container, it's alive, it's aware, you don't have to do anything manually. And it isolates each of the clients. Instead of having a bunch of named vhosts, each one has their own container. So it's isolated. So theoretically, if one goes bonkers, if somebody gets hit with a spam bot, if one gets hit with malicious code, it's only going to take down that container. And then how do you get back? Well, if you've architected it pretty much this way, pretty much all you have to do is just relaunch the container from the image and you're back to square one with all your settings and all your data intact. It's pretty cool. How do you make it better? Multi-host applications. This was all on one. I've been working with, there's something called Docker Swarm, which is a way of clustering a bunch of Docker containers. So or not Docker containers, Docker hosts. So you get away from having to provision to a host, and you just provision to a cluster. And then the cluster, depending on the strategy you've used for it to decide what hosts to put containers on. I use one called Spread. It kind of looks at how many containers are running and the CPU load and that type of thing. And that's how it decides where to put containers. And so if you launch a Drupal app like that, you can actually just have it launch Drupal. One Drupal container may be on one host and the MySQL container might be on another host. It doesn't matter because making it better includes that service discovery so that they know about each other. You get away from having to have it on a single host. There's some things that you do want to be on the same host. In the Docker Compose file, you can actually set affinity.
How do they discover the services?
I use Console. Console's pretty cool. It's by the same people who wrote Vagrant, HashiCorp. And so I use essentially what my stack is I'm using I use Docker Swarm for the cluster. I'm testing between Calico and Weave networks for the overlay or mesh network across all the instances. But on every one of the hosts, I'm running something called Registrator and I'm running Console. And what happens is Registrator listens to the Docker socket. It knows when a new Docker container comes up. It registers it with Console, and Console actually has an embedded DNS server so that you can look up mysql.console.service or mysql.service.console, whatever the name of your container that came up. It'll look up an IP address, which is on that mesh network that you've created. And then that's pretty much it. And in all my containers, I point them to the local name server primary. So it's like 172.42.0.41 or whatever the Docker IP address is. And it's pretty automatic. And I also use console template, which also listens to this. And it's what rewrites either the HA proxy config or the Nginx config. And again, it's all templated and it's all pretty automatic.
Might be a stupid question, but when you say that so you're talking about swarms and
Yep.
having Docker containers potentially deployed to different hosts,
Yep.
running on different hosts,
Yep.
and how to connect them when that happens.
Yep.
And you mentioned that one thing that happens is that you can just manually give it an IP of the kind of the head of the swarm or the main host or something.
Well,
Is that something that you put into the container? Like, do you have to hardwire IPs into the config?
no, you don't, because what you're doing is in the config, what you do is you use environmental variables. So the environmental variable would be like DB underscore host. And when you launch the container, it's going to find, you populate that variable for where it needs to look, and it will do a DNS lookup because that services come up, and it'll be like an affinity type of thing. Like if you looked at the names of those containers, it was like Docker Drupal underscore MySQL underscore 1. So it's going to look for that.
Gotcha.
Because it's part of that stack.
Okay, so when you're defining the container,
Yep.
you set environment variable, or you refer to environment variables,
Right.
And then when you're launching the container, I noticed one of the lines you had an environment variable set. I just didn't notice it that way.
Yeah.
Gotcha.
So you set them there.
Like passing in parameters.
Exactly. And each of them is isolated. So DB host, if you use DB host may be completely different in one container than it is in another container because it's part of a different stack. So then you can really get fancy. You get away from Swarm. You get into Kubernetes and Mesosphere and all these huge orchestration tools, which are really, really cool. But that's for a whole different talk. And then just more containers, like I mentioned, you toss on Memcache, toss on HA Proxy, Nginx, Redis, all of them running containers. And using an architecture like that, you just have them all talk to each other. Right now, it's, what I say is what I'm using might not be the right one for you. It's what I've gotten used to. And some of it is because I started working on this, when Docker was like 0.02 or something like that. I mean, I've been working on it for quite a while. I still have a lot to learn, and the space it's changing so rapidly right now. I mean, I can't keep up with it. I try, but there's just so much out there. Like I'm using Console for the DNS. However, Weave, which is one of the networking layers, has its DNS, and it's also got a visualization platform, so you can visualize really easy every container in your network. I mean, it's really cool. Do I have the time to yank out the guts of what I've got already and put that in? Well, I'm gonna have to test Weave. Calico is the one. I started with Weave, moved over to Calico a little bit, but they're leapfrogging each other, so it's really, really rapid, which makes it really, really exciting. But the big thing, above all, is automate. Right now, my images are being built using Jenkins. And it's using basically just typical Jenkins. It watches for a git change. Or a git commit, and when I make a commit, boom, there's a new image built. So that's it. I'm testing deployments using Jenkins, but I'm not sure if that's the right way to go. And I know you and I talked about that a little bit too. So
I've had that, like going to production with Jenkins always seems like the wrong idea.
Yeah. So I'm gonna be exploring that. For that type of thing. There are other ways of deploying that are probably better. So. Yeah. So anyway, if you want to download my Docker Drupal directory, which has the Docker file in it, it's got the Docker Compose file in it, it's got the sources so that you can actually launch your own built Drupal container. You just go there and just do a git clone. We also run the Western Mass Docker Meetup. Go to meetup.com and you can check it out. And you can contact me, mklatsky at esperdyne.com. @mklatsky is my personal Twitter. You can also contact me at @mapukakis, but that's where I toss my political stuff in, so you might get offended there. And at Esperdyne, which is our company Twitter. I think that's about it.
Question about the economics of this, because I love that Docker allows for a vendor agnostic approach to essentially what Amazon has done so well in its Elastic whole Elastic stack.
Yep.
So I can use AMIs instead of Docker images, and I can use their load balancer to spin up based on load and all that.
Right.
How do the economics work on doing this in a Docker situation where I have one large machine or a cluster of machines versus using an Elastic load balancer and AMI images that are spinning up and then creating new images and everything, and the AWS Redis or whatever I'm using.
Right.
How does that work out financially? Like from
Yeah, I can't really answer about that financially because I've not really done a financial analysis of that. I know what our monthly spend is on the Amazon services. One thing that I like about this approach, you mentioned vendor agnostic. I love a lot of the Amazon tools. They make it part of what Docker is doing and part of what Amazon has begun to do is my gut and in my head theory is that I don't want to worry about machines. I don't want to think in terms of machines. I want to think in terms of toss the service up there and somebody else handles the there. And I mean, I spent a good part of my career handling crawling around data centers and whatnot. I want somebody else to handle that, and not just you have all the hardware to do it. I just want to make it easy to deploy. I don't want to think about, does this host have enough RAM? Oh, I need to upgrade to more RAM because it doesn't have enough memory. Oh, gee, you know, and you're always, as you know, the typical thing is, you know, you remove one bottleneck and all of a sudden another bottleneck that was always there but didn't expose itself happens. So all of a sudden now you fix your web server design, and all of a sudden now your back-end databases are chugging on you. Why? Well, they always had the problem, but they never got enough traffic to expose it. So what Docker does and what Amazon does is it allows you to eliminate a lot of the there. And but Amazon, you're very tied into Amazon.
Oh, absolutely, which is what Docker's beautiful. And there's clustering. I could do a service across Linode or AWS,
exactly,
all the clouds, and not worry about East Coast AWS going down.
Exactly, and I've got one swarm that's running. I've got 2 machines in DigitalOcean in 2 different data centers, and I've got 4 machines running at Amazon, 3 on the East Coast and 1 on the West Coast. And I deploy, and it doesn't matter where it goes to. Obviously, all on the same network. Now that's because of running Calico, because it's all now. You still have the vagaries of the one on the West Coast, even though it's on the same network. You still have the WAN that you have to talk about. So it doesn't eliminate everything. It doesn't eliminate the physics, but it does allow you to be more agnostic and put stuff out in different areas. Mike, you had a question?
Yeah, I just wanted to expand a little bit. So a lot of this also is not, you know, thinking about it in terms of saving money. It's in terms of, like, from the development standpoint, he tends to think about things from the system side. As a developer, being able to break things down into services, like I was just thinking about earlier on your slide where you said automate. Like, this whole methodology, almost like it's this new technology that is kind of encouraging best practices, because you make, instead of making, you know, doing a one-off and installing, you know, MySQL and this version of Python and this thing, you make a formalized recipe, and you deploy it. So one of the things that I encounter a lot as a search architect is we have these huge monolithic service-oriented architectures that have all these different parts. And then some of them, you know, there's like, you know, configuration server or like reporting, that might be like one part. But then we have document processing services that, you know, a particular server might be able to handle 6 instances of those. So by breaking everything down into these Docker containers, it makes it much easier to make it into a service, even though what's inside the container might be dumb. It may not have any concept of multiple threads, performance, stuff like that. So by putting them in the sandbox of a container, I could run stackless Python in this particular Docker container, and this one might have to use some ancient legacy Python 2.3 or something. So it just makes it so much easier from a service-oriented architecture or plug and play to deploy things that might have been developed at different time periods or whatever, and keep them from colliding. Whereas if I tried to run multiple Pythons, or, you know, we've even had issues with like PDF processing libraries for content processing, that, you know, we needed to have really specific versions that by containerizing them, it just gets rid of so many headaches for us.
Yeah, well, I mean, I have a testing server that runs 3 versions of PHP and concurrency.
God, yeah. So just,
which was fun to put together.
Yeah. So just, you know, I'm super excited from the development standpoint to be able to break everything down into sandboxed services.
Yeah, and so to get back to your point, I can't speak to the financial part of it, but I like to be as agnostic as possible. So like I would prefer generally running my own Nginx or HA proxy server at Amazon rather than ELB, just because I can control it more. And once it's done, it's done. And then using some of these technologies, I get the same benefits that ELB gives me.
Oh, I no.
And
There's no
so that's what I
question there.
like, because then I
Yeah.
can port that to Rackspace or DigitalOcean or GCE or,
Whoever,
you know,
Yeah, the
I
portability.
love the ability to do that. The other thing that I like, and this is not a production thing, but it's something that I've been thinking a lot about in testing, is Amazon's auto-scaling, I think sucks. I just don't think it's really great, because you still have, there's a lot of latency. You're limited as to how you
mean,
determine
like the
when you,
Elastic Cloud.
It takes 20 minutes to spin up a new box.
right,
If so they'll let you.
right. And yeah, there are some times where, you know, things happen like, oh, you have too many SSD drives in one region and you hit that cap, that type of thing. So what's really nice is being able to scale with containers. As long as you've got your swarm up there, you can scale up. What's really nice is when you scale up with a container, because I can bring up duplicates. The Docker Compose command, you do Docker Compose scale web, and it'll bring up a new one. Only they're up like that, and they're registered with the service, and they become part of your load balancer instantly. So all of a sudden now you have another web server that came up in an instant. Did have one question at the last Docker meetup. What's the difference between running one Apache web server with 20 vhosts as opposed to 20 containers running Apache? Well, to me, the difference is, and from what I've seen is, I find that even when they're all being benchmarked at the same time, one Apache host it uses more memory and it chugs much more than using a bunch of individual containers. Secondly, you've got isolation too, because one of them goes down, the other ones are okay. Whereas we all know what happens if one vhost gets clogged. Guess what happens? All of a sudden, everything grinds to a halt. So, you know, that isolation is really
Doesn't that
good
make
there.
all the others stronger?
Oh,
All the
yeah.
other hosts get
Yes,
they,
exactly.
they rise to the challenge.
Exactly. And you can look at it in your D message and your
It's based
error
on
logs.
its extra bandwidth.
Yeah. So, yeah, so, you know, from that standpoint, it's really nice. And with a whole bunch of vhosts on one system, if you're overloaded, guess what you have to do if you want to move to another system? You got to move the code. You got to move the config. So with containers, you just move container to another one.
And also, if there's an issue with, like, you can't provision for some reason more on Amazon because they're having an issue, I mean, because they're containers, I mean, you could spin up some DigitalOcean,
Yep.
containers, and then point them at your load balancer, and
And to be part of the same.
have it be part of the swarm, even though it's a completely different, subsystem.
Yep.
So
So anyway, so it's 5:06. I think that's kind of the end. Does anybody have any questions? Any more questions? I've been kind of going on a tear. So as you can probably tell, I'm kind of excited about this technology. So do I have to stop this?
Yeah, stop it.
I feel like this will take me a while to wrap my head around.
It will. And email me if you have any questions. You know, email me and come
I'm
to the
thinking of
meetup.
joining that group.
Yeah,
Yeah,
definitely
that
come
was
to the
one.
meetup.
Seems like a very specific topic for a group, but it's a big topic.
It's a big topic, and